Okay, hello everyone. I'm Diksha. I'll be taking your live session for the course um, Basic Calculus floated on NPTEL, and we'll having a live session every to 8 p.m. So I'll wait for students to join for like 5-10 minutes, and then we'll start with the question. So yeah. Okay, let's start. So, so I'll be doing some questions so that they can help you with solving the assignments uh, of your NPTEL course. Okay, so let's start with the first question. Okay, so if you guys have seen the videos of week one, so some of the topics that were discussed there were the Archimedean property, completeness property, about the interior points of the set, and graphing of some functions, and also about uh, inequalities, including the modulus, and also about yeah. Okay, so I'll be doing questions based on these topics itself. Okay, so the first question is, solve the inequality. So you have to solve this inequality. Solving this inequality means you have to find the value of x. Now you know that since mod x can take two values, either x or minus x. Now, depending upon, I should write it in a better way, depending upon x if x is positive and minus if x is negative. Now x minus 1 will can be, so mod of x minus 1 is x minus 1 when x minus 1 greater than equal to 0, and minus of x minus 1 when x minus 1 less than equal to 0. So we'll make two cases. When x minus 1 is greater than equal to 0, that is x greater than equal to 1, then the given inequality is becomes x minus 1 greater than equal to 2 implies x greater than equal to 3. So now we want both of these conditions to be satisfied. Condition 1 and condition 2. So 1, 3x is greater than 3. So the intersection of both, so of both the conditions 1 and 2 are 2 is x greater than equal to 3. So the given inequality will be satisfied by all those x belong to the real number such that it is greater than equal to 3. Now case 2 can be when x minus 1 less than equal to 0, that is when x is less than equal to 1. So the given inequality becomes minus of x minus 1 will be, what was it, greater than equal to 2, right? That is minus x plus 1 greater than equal to 2 minus x greater than equal to 1. X multiply with the negative changes the inequality, so the x is less than equal to minus 1, right? So we want both the conditions 3 and 4 to be satisfied. That is, if you plot it on a number line, it is easier to see the conditions when we plot it on a number line. So we want x to be less than equal to 1 and x to be less than equal to minus 1. So the intersection of both the conditions 3 and 4 are x less than equal to minus 1, right? So by 5 and 6, so whenever there are such kind of questions, majorly students get confused that whether you have to take intersections of the condition 1 and 2 or 3 and 4. So you have to think about it, that we want that condition, that case 1 in okay, so just to simplify it, in different cases we take the intersection, but of both the cases we'll take the union. What I meant is that in case 1 the condition 1 and 2 both need to be satisfied, that is why we are taking the intersection. And in case 2 and again in case 2 both the condition 3 and 4 we want to be satisfied, so we are taking the intersection. But now we have to combine both of the cases, so this given inequality, so two cases meaning that x can belong to either case 1 or case 2, which means we have to take the union. So the given inequality is satisfied by all x belonging to R such that x belongs to minus infinity to minus 1, this condition 6 union the condition 5, 3 to infinity. So this is our solution. Okay, I hope it was clear. Now question 2, I'll do a similar question just to brush things up so that it is clearer to you guys. So question number 2 is again on an inequality. Solve the inequality 1 by mod x minus 3 less than 1 by 2. Alright. Again, we'll make two cases because we have mod. So case 1, when x is greater than equal to 0. Also notice that here it was less than equal to, so that's why we have included the endpoints in every inequality. But whenever there is a strict inequality, you have to be careful. Now when x is strictly greater than equal to 0, then implies mod x is x. So this will imply, so given inequality becomes one by x minus 3 less than 1 by 2. So you just have to solve it now. So there can be a couple of techniques to solve this. So I'll just uh, bring each of this to one side. 1 by 2 less than 0. So this will become 2 minus x minus 3 upon 2x minus 3 less than 0. So this becomes 2 plus 3, 5 minus x upon 2 into x minus 3 less than 0. So now what can happen? That this fraction can be less than 0 when either of the numerator or the denominator is less than 0. So again, case 1, 5 minus x is greater than 0 and x minus 3, this 2 will not play any major role, and x minus 3 is less than 0. Or case 2, 5 minus x is less than 0 and x minus 3 is greater than 0, right? So this becomes 5 less than x and x less than 3. Sorry, it should be 5 greater than x, right? So now you have to take the intersection of both 3, 5. So x is less than 3 and x is less than 5. So in this case, x belongs to, this is the intersection 3 to infinity. And it is strict, so we will not include 3 here. I'm sorry, minus infinity to 3, because now here it is 5 less than x and x greater than 3. So 3, 5, 5. So in this case, x belongs to 5 to infinity. But you also see that we had the condition that x is greater than equal to 0. But in this case, x is greater than 0. So we'll have to take the intersection of both these cases with x greater than equal to 0. So it will become, this is already positive, this will become x. So x belongs to 0 to 3 union, this case 5 to infinity. Okay, so this is what we have got the x in this case. Now case 2, similarly, when x is less than 0. Now when x is less than 0, what do you have? In fact, here x was greater than equal to 0, so we can include 0, right? Now here x is less than 0, so the given inequality becomes, what will it become? 1 by minus x minus 3 less than 1 by 2. So this is 1 by minus x minus 3 minus 1 by 2 less than 0, 2 minus x minus 3 upon 2 into minus x minus 3 less than 0. So this becomes 2 plus 5 plus x upon 2 minus x minus 3 less than 0. I'm taking x common, negative common from the denominator, it becomes 2x plus 3 less than 0. Right? So if this 2 is confusing you, just can take 2 to other side to get x plus 3 is less than 0. Now again two cases. You can write it as case 1a, case 2a. Sorry, case 1b, just to avoid the confusion. Case 2a and case 2b. So this can be less than 0. The fraction will be less than 0 when either both of them are no, sorry, if one of them is positive and the other is negative, right? Have I done some mistake here? Yes, when, okay, sorry, this will be positive since I took the negative common, right? So this a positive fraction when both are either negative or both are either positive. So one case is this greater than 0, x plus 3 greater than 0, case 2 is 5 plus x less than 0, and x plus 3 less than 0, meaning x greater than minus 5, x greater than minus 3. So this is minus 3 minus 5, x greater than minus 5, x greater than minus 3 implies the intersection x greater than minus 3. Now x less than minus 5, x less than minus 3, so we'll get minus 5 minus 3 minus 3 and minus 3 implies x greater than minus 5. But in case 1 we have x less than 0 implies x, case 2 we have x less than 0, so we'll take the intersection with both the cases, right? Sorry, x, yes, x is less than minus 5. So x greater than minus 5, it will be x belongs to minus 3 to 0 union minus infinity to minus 5. So now combining both cases 1 and 2 implies x belongs to minus infinity to minus 5, just writing in the order of the real line, union minus 3 to 0 union 0 to 3, 0 can, because 0 is also included, 0 to 3 and union 5 to infinity. All right, so this is our final answer. Okay, I hope it's clear. Moving on to the next question. So there was something called Archimedean property, which was also discussed in the class. So I will do some questions on that. So question So question number 3 is, use the Archimedean property to prove that intersection n equals to 1 to infinity, 0 to 1 by n is phi. Right? This is this question says that the intersection of countable intersection of the intervals 0 to 1 by n, when where n is belonging to n, is empty. I'll just wait for you guys to give this a try. Okay, so just to recall what the Archimedean property says, it says that given two positive real numbers, a and b, there exists a positive integer n such that n is greater than b. Basically, for any real number, you can find a natural number greater than that, because the idea is natural number is the set of natural numbers is not bounded above. Okay, so what does this question say? Now then you have to prove the intersection of how does this look like? So 0 n equals to 1, 1, 1 by 2, then 1 by 3, 1 by 5 will be less again. I don't go on the scaling, you're just getting what I'm trying to say. So you see that if we take the intersection of all these sets, it cannot be uh, finite or singleton anything. It has to be 5, because when if suppose if there is an element, we can find using the Archimedean property a number such that it is not in the other sets below that. So what I'm trying to say, let me write it down. So suppose y belong, we'll go by contradiction, y belongs to n equals 1 to 3, 0 to 1 by n, the intersection, right, implies y is greater than 0, right, and y is less than 1 by n for all n belong to n, because y belongs to intersection, and so it will be in each of these sets. But by Archimedean, what we can find? Archimedean real numbers, there exist m belonging to natural numbers such that what can happen? Y and m are positive, and 1 is positive, we can find 0 less than 1 by m, or you can say such that m into y is greater than 1, right? Or y is greater than 1 by m, because 1 is also a natural number, or in fact a real number, so 1 by m less than y, and this is positive. Implies 0 less than 1 by m less than y. Now you see what was our assumption, that y is less than n for 1 by n for all natural numbers, but we have found a natural number such that y is greater than 1. Implies this contradicts our assumption 1. That is or we can say y does not belongs to 0 to 1 by m. Implies this contradicts our assumption, implies in intersection n equals to 1 to infinity, the interval is nothing but an empty set. Okay, I hope it's clear. Next question is basically a calculus question talking about the maximum and minimum of a set, or infimum or supremum of a set. So question number 4. Consider the set. Again, the set of natural number and belong to 1 by n, and by 1 by n, where n belongs to the natural numbers. So a part is show that maximum of s is 1. That is, x is the maximum of the set. That the maximum of the set is the number 1. Second is show that if d is a lower bound for s, then D is less than equal to 0. What do you mean by lower bound? That any element of the set will be greater than this number. And lastly, use the above part to show that 0 is the infimum of the set. What is the infimum? That there can be many lower bounds, right? That elements of the set are greater than that. Then any number below after this D will be the lower bound, right? But less than D will be the lower bound, but you have to find the greatest lower bound. Okay. So first part, C, X, you have to show that 1 is the maximum. For maximum, you will have to show that any element of the set is less than that number. So let X belongs to arbitrary element, then X equals to 1 by n for some n greater than equal to 1 implies X equals to 1 by n is less than equal to 1. So implies that 1 is an upper bound. Now to show that it is the maximum, you will have to show that it is the least upper bound, meaning that there cannot be any number less than 1 which is the upper bound of the set. So you just have to note that 1 belongs to S, because for n equals to 1, 1 by 1 is 1. So 1 belongs to S implies that 1 equals to maximum of S, right? Because since we have shown that any number in the set S is less than equal to 1, and in fact 1 is in the set, so maximum has to be 1. So any number, there does not exist any number which is greater than 1, because by 1 we have shown that because we have already shown that 1 is any number is less than equal to 1, right? So they show that 1 is the maximum of the set S. Now B part is what I actually wanted to do, because it includes, again, it is an application of the Archimedean property. So you have to show that any lower bound of the set is either 0 or negative. So let D be a lower bound. So meaning that this is D, this is lower bound, so all the elements of the set belong here. Now D is a lower bound, so any number less than D are all lower bounds. But we have to show that D is the greatest lower bound, meaning D is the greatest lower bound, but that will be used in part C, because there we will have to show that it is the infimum. So firstly we have to show that D is less than equal to 0. Now again we'll go by contradiction. Since D is a lower bound of the set S, implies for every S belonging to S, we have S is greater than equal to D, right? Assume, on the contrary, that D is positive, right? implies using. So can you also visualize it? Because if there is a number which is positive and there's a lower bound of the set, then we can always find a number. Lower bound means it is the smallest. We can always find a number smaller than that using the Archimedean. So these are all the set of 1 by n. Okay. So using Archimedean property, we know that there exists a natural number, there exists n belonging to the natural number such that, like we did in the previous question, Dn is greater than 1, right? Also, since n is positive, so Dn greater than 1 implies D is greater than 1 by n. But 1 by n belongs to S and D is a lower bound. So this cannot happen because every number is greater than C. We have found a number which is less than C. Contradiction implies our assumption was wrong, implies D is less than equal to 0. So we have shown that the lower bound of the set, every lower bound of the set is in fact less than equal to 0. Now C part says you have to show that 0 equals to infimum of S. Infimum means greatest lower bound. This is easy. This can you can see trivially by the part B, since every lower bound is less than equal to 0 by B part implies greatest lower bound, I denoted by GLB, greatest lower bound is 0, implies infimum of the set S is 0. Okay. So these were some of the applications of the Archimedean property. Okay. Just give me a minute, I'll be back. Okay, so next we'll move on to discuss some question on interior point. I'll just do an example. So this was question number 4. Interior point. So what is an interior point of a set? Let S is contained in, let S be a set contained in the set of natural numbers. A point X belongs to S is called an interior point if there exists a neighborhood N of the point N X such that Nx is contained in S. Okay. So it says that there exists neighborhood, and neighborhood in R is nothing but a interval around X, X minus delta, X plus delta. So you have to show that find the interior point of the set A equals all the rational numbers Q between minus pi to pi, just denoted by R. So you have to find the interior point of the set. So if you see, let X belongs to interior of A, means X is an interior point of set. Implies there exists a neighborhood of X, or say there exists delta greater than 0 such that X minus delta and X plus delta is contained in A. But if you see that this interval contains irrationals, but A is contained in set of rational numbers, so this cannot happen. So right, because between any two rational there exists an irrational. We have studied this in the week lectures. Sir has discussed this. So this cannot happen implies there exists no such X. Implies interior of the set A is empty. Okay, so you have to, so exercise, just a simple exercise, you have to find the interior points of the set B equals 1 by n again. So a famous, or you can say good set with so many properties you can learn from this type of set, right? Okay. Next, I want to do some questions on the domain and range of sets. Sorry, functions. So the question is, So this was question first. Question. Find the domain and range of the following functions. A part is fx equals to x minus y. Sorry. So this is a function in R2 f, or I should rather write it as f from R cross R, meaning this is the tuple to up, where fxy is 1 upon x minus y. So you'll have to find the domain and range of these functions. For this function to make sense. This function will make sense for every x and y in R2 except when x and y is 0 because it is belonging to the denominator. So clearly domain of f is xy belong to R2 such that x is not equal to y. Right? Now for the range, you have to think a little. So you see that the whole of R cross R is the domain. You have to see what are the possible values this function can attain for x and y in the domain. Okay, so note that for z, for some z not equals to 0 belonging to R, f of 1 upon comma 1 minus z 1 minus 1 minus, I just apply the definition, this comes out to be z. So we have found a pre-image of the any point z. So we have found a pre-image of any z non-zero belonging to R, implies all z belong to R minus 0 is contained in range of f, the function f. And in fact, range of the f, and further, you have to see if only the possible value for the range of this function can be R, right? The real number, whole of the real number. So we have found that every real number except 0 has a pre-image, implies that it belongs to the range. So we just have to check, does 0 belongs to the range of the set of the function. If 0 belongs to range of f, implies there exists some z tilde belonging to, or there exists x tilde y tilde belonging to R2 such that fx tilde y tilde is 0. Now what is the value of fx tilde y tilde? 1 upon x tilde minus y tilde equals 0. This is not possible. Implies 0 does not belongs to. This obviously is not possible for any x and y, for any real number x and y. So 0 doesn't belong to range of f. Implies implies range of f is contained in R minus 0. So and we have shown that every z non-zero belongs to the range of f is contained in R minus 0. So by 1 and by 2, implies a range of f is r minus 0. Okay, so you have to think, visualize the function a little. Alright, so how does, I mean, this function x minus y for x belong to R can take any value we wanted to take. If you think about it like that. So we have found one of the pre-images of a given number, non-zero number in R. In fact, this pre-image can be some other number also, right? This is one of the cases. So to find the range, you have to see what type of function it is, or just try to visualize the function. All right. Now, some more examples. A, B part. Fxy, we are given f from R cross R cross R to R. Three tuples, not tuples, in R3. So fxy is, that is 1 minus x square minus y square minus z square. So the domain is clearly f is defined when the under root is positive. Clearly domain is f is defined for all xyz belonging to R cross R cross R, such that 1 minus x square minus y square minus z square is less than equal to 0. Sorry, is greater than equal to 0 for under root to be defined. So 1 is greater than equal to x square minus y square plus z square, implies domain of f is all those x, y, z R cross R such that x square plus y square plus z square is less than equal to 1. Basically the interior of the sphere in R3. Now to find the range. Okay, so let's see. Let T belongs to range of F. Implies there exists x tilde, y tilde, z tilde belonging to the, meaning that T has a pre-image. So pre-image I am assuming x tilde, y tilde, z tilde belonging to the domain of F, such that F is, that T is the image of this number, such that f x tilde, sorry, f x tilde, y tilde, z tilde is T. Right, now we put the value of f, 1 minus x tilde square minus y tilde square minus z tilde square is equal to T, implies 1 minus T square is x square tilde. Now, like now, x plus y square plus z square and is less than equal to 1. So 0 less than 1 minus T square, you have to find where T belongs. So this is the one of the inequality. We can clearly see that at least 1 minus T square will be in this range, right? So you get, implies if you minus 1 less than T square minus 1 less than 0, I just multiplied with the negative. So 0 adding 1 is less than 1. So T square greater than equal to 0 for all T. This gives, and you have T square less than equal to 1. So T square minus 1 less than equal to 0. So T minus 1, a square plus b square identity is less than equal to 0. Implies T belongs to, it's less than, so you will have to include minus 1 and 1. Minus 1 and 1. So what we have gotten is, we took any number in the range and we have found that that number will at least belong to minus 1 to 1. So we have found a range of f is contained in sorry, also note that this t also by 1, this one, there is one condition more that t is greater than equal to 0. So combining both these conditions, we get t belongs to 0 to 1. So we have gotten that for any number in the range, it will at least belongs to this interval. Implies the range of f is contained in 0 to 1. Okay, so you're not till now exactly found the range. You have found that range of f will at least be in 0 to 1. Now to show range of f is exactly 0 to 1, we will use something called intermediate value theorem. Intermediate mean value theorem. What it says that, so you will study it later in the course. Later, I think it is in the course that if f is continuous, of if you don't know what continuous is, you can skip this part and come back to it later. So if f is continuous, and if f is attaining 2 points, that is just roughly for a continuous function g, if there exists x belonging to the domain of g and y belonging to domain of g such that gx equals to some c and gy equals to d, implies that, meaning that if uh, c and d are in the range of g, implies there exists some e belonging to c and d to the interval formed by c comma d. Without loss of generality, we are assuming that c is less than d, such that what happens, sorry, and for without loss of generality, c less than d, let e is in between, let e is such that, let a number, let e belong to r is such that e is between c and d, implies there exists, so the intermediate value theorem says that there exists some z belong to domain of g such that f of g of z is e. Meaning, if I tell you what it is saying, that if this is c and d, it is attained by some x and y, and this is the function, some function g. So if g is continuous, meaning that it has no break, just not to tell it mathematically, then any number between this c and d will have a pre-image, meaning it will, if it attains two numbers, then any number between those two numbers has to be attained by the function. So now coming back to the question, if I show that, you have to show that range of f is 0 to 1. So if I show that 0 and 1 belongs to the range, me 0 and 1 of course belong to the range. So if 0 and 1 belongs to the range, so whole of the set has whole of the interval between 0 and 1 has to belong to it. So we have already shown though that it 0 and 1 belongs to the range, but to be more precise, note that f of 1 comma 0 comma 0 is 0 and f of 0 0 0 is 1, implies any number between 0 and 1 belongs to the range of f by intermediate value theorem. Implies 0 and 1, 0 to 1 is contained in range of f, thus hence range of f is 0 to 1. I hope it's clear. If this plot is not clear, though, no, sorry, not to be more precise, we just have shown that range of f will be in 0 to 1. So we want to show that range of f is exactly equal to 0 to 1. We are showing that 0 and 1 both are retained, both are in fact in the range. So this will imply 0 comma 1 belongs to range of f. So any number between them has to belong to the range of f by intermediate value theorem, because as f is continuous, that will not take any break, because you can visualize it as a function x raised to power 1 by 2 in real number. We are here in r cross r cross r. Okay. Now, next question again. I'll give an exercise. C part. Find the domain and range of the function f from r cross r to r, and fx comma y is 16 minus 4x square minus y square. Similar to the above question, very similar. Okay, just try it. I'll do one more question on range and domain. B. Again, find the domain and range of the function fxy equals 4 minus x square minus upon y square plus 3. Now the domain is clearly you can see the fxy is defined when 4 minus x square is greater than 0. The denominator has no problem, it is always positive, because y square is, that is 4, that is as we did below, did above, x belongs to minus 2 to 2. Y square plus 3 is always positive for all y belong to R. So the denominator is no problem, implies domain of f is all those xy belong to R2 such that minus 2 less than x less than 2. Now range. Now as we have done earlier, I'm just seeing at least the set where the range is contained. Okay, and that I'll do by seeing where the denominator and the numerator belong for this domain of F. So now for range, observe calculated as in above cases. For the numerator, the range of F is a range of the function 4 minus x square is 0 to 2. You can calculate it as in the first question. Further, y square plus 3 is greater than 0. Y square positive always is greater than equal to 0. So it is greater than equal to 3. So y square plus 3 belongs to 3 to infinity. Okay. And this is the range, and in fact it is the range of y square plus 3 because, and since 0 plus 3 equals to 3 implies it will take every value between 3 and infinity, implies the range of y square plus 3. Again, it is a continuous function. If you want to go in detail, you can again use the intermediate value theorem, but it is pretty clear here. Okay, so range of y square is 3 to infinity. So now our fxy will be positive, is always positive. Fxy is greater than equal to 0 and less than equal to 2 upon y square plus 3, because the numerator is always less than equal to 2, and which y square plus 3 is greater than equal to 3. So 1 upon y square plus 3 is less than equal to 1 by 3. So this is less than equal to 2 by 3. Implies fxy belongs to 0 comma 2 by 3. Implies the range of f means is contained in 0 comma 2 by 3. Now if we show that 0 and 2 by 3 are in fact in the range, so every value between them has to be in the range because f is again continuous. So then we'll be able to show that in fact 0 to 2 by 3 is the range. So this now for x comma y equals 0 0, we have fxy equals 4 upon y square plus 3 3. This is 2 by 3. And for x comma y equals 2 comma 0, fxy is 0. Implies any number, implies 0 comma 2 by 3 belongs to range of f, implies any number between 0 and 2 by 3 belongs to range of f, and we have already shown that range of f cannot go outside to the interval 0 comma 2 by 3. Thus range of f is 0 comma 2 by 3. Okay, I hope it's clear to everyone. Okay. Okay, so now the next question I'll be doing on the symmetry of functions. Okay, so just to sorry. This is question number 7th, right? Symmetry. So how to check the symmetry of functions? Just to give you the visualization, that just consider an example. So this function is symmetric about y-axis, meaning any point positive and any point here. If I take x minus x, they're taking the same value. Now this is symmetric about the x-axis, meaning that for any y positive and any y negative, the graph of the function is the same. And this is symmetric about origin, means any x positive, it is the same value, x positive and it is the same value, and for any y positive and negative, it is the same value. So how do we write it? X-axis symmetry occurs if y replaced with minus y yields the same equation. Same equation, that is the equation of the graph, which involves y and x. Y-axis symmetry occurs if x replaced with minus x yields the same equation. And origin x replaced by minus x and y replaced by minus 1 minus y yields the same equation. All right, now examples. Y equals x square plus 4. Check what check for question is check for symmetry with respect to x-axis, y-axis, and the origin. A part is y equals x square plus 4. Clearly, x by minus x, y equals minus x square plus 4, x square plus 4. So, symmetric about y-axis, right? But y replaced with minus y equals minus y equals not the same equation. Because we have y instead of minus y implies not symmetric about x-axis, and since not symmetric about either one of x-axis and y-axis implies not symmetric about origin. Okay, b part y equals minus x cube minus x. Now x replaced with minus x, we get y equals minus of minus x cube minus of minus x. So what do you get? No, this will not imply this, okay? Also, when you have to simultaneously replace x and y with minus x and minus y to check the symmetry about the region, so implies since it's not, minus y equals minus x. Not symmetric about origin. Alright, so this is x minus x cube again, plus x cube plus x. So not same equation, not about the y-axis. Y replaced by minus y equals minus x cube minus x, where y equals x cube plus x. Not about, not giving the same equation, so not about x-axis. Origin minus y, we get minus y equals minus of minus x cube minus of minus x, which gives minus of x cube plus of x cube plus x. Y equals, taking the minus here, so it is not symmetric about x and y axis, so same equation implies symmetric about, not symmetric about x and y axis, but it is symmetric about the origin. Okay, y equals 2x minus 10, so x 2 minus x, y equals minus 2x minus 10. X-axis, sorry, y-axis not symmetric. Then y replaced with minus y equals 2x minus 10, again not, sorry, with यहाँ पे y-axis and x-axis again not, and y equals to minus y minus 2x minus 10, y equals 2x plus 10, origin not symmetric, so symmetric about none. None of x, y, and origin. Okay, so next is x square plus y square and equals 25 circle. So clearly x, y is replaced minus y, x by minus y because of the presence of the square. Clearly it is symmetric about all of the three, x-axis, y-axis, and origin. Okay, E part, y equals mod x plus 2. Now clearly because of the mod, x replaced by minus x implies y equals to minus x plus 2 equals mod x plus 2, implies symmetric about y-axis. And this y replaced by minus y equals mod x plus 2, not about x-axis, not about origin, okay, of course, you can see that. So one exercise you can do, x equals, or have I done this? No, right? X equals minus y square plus 4, checksum 3. Okay. So one question next I will do on composition of functions. Just a simple question. So this is question number 8. Okay, before that, let's do some graph questions on graphing. For that, you will have to see shifting formulas. Okay, so what does this say? That if y minus k equals to fx, shifts the graph of y equals fx by k units up if k is greater than 0 and k mod units down if k is less than 0. Alright. तो अगर y में हम k माइनस कर रहे हैं, k पॉजिटिव है, तो इट विल शिफ्ट द ग्राफ k यूनिट्स अप, राइट. सेकेंड इज अगर x में चेंज कर रहे हैं, दिस आर vertical shifts. If we change in y, horizontal shifts, if we change in x. So if y equals to x minus h, shifts the graph right h units if h is positive. Okay, so if x minus h, if x is positive, right, and a graph of y equals to fx, of course, and shifts the graph left mod h units if mod if h is less than 0. So now we'll use this to graph some functions. Graph the function y equals 1 minus x minus 1. So this is nothing but x is minus x mod is x mod. So this is x minus 1. It is easier to visualize this way. So graph firstly y equals to mod x, of course, because this function contains mod, you just have to then shift the graph. So y equals mod x looks like, right? And sorry about my right. What we'll do, y equals mod x changing in x, okay, by the horizontal shift. Mod x y equals to mod x minus 1 will shift the graph 1 unit. So this will be x, y is, this is mod x minus 1. When x is 1, it is 0. When x is 0, y is 1. Now with this graph, you have to change in y. So we have to plot y plus 1 equals mod x minus 1. That is y minus minus 1 is mod x minus 1. So here our k is negative. So it will shift the graph 1 unit downwards of mod x minus 1. So if this is minus 1, this is 1. So it will shift the graph here. And for x equals to 0, it is 0. So for x equals to 0, 1 is equal to, for x equals to 0, y equals to 0. So it will pass to 0, 0. So this is the final graph of y equals x minus 1, or y equals in fact 1 minus x minus 1. So this is how the shift formulas are very helpful. You can easily plot the graph of this function, which looks a little complex at first sight, just using the graph of y equals to mod x, which is very easy to remember. Okay. Next is graph the parabola y equals 3 minus 2x minus x square. So for graphing, we have to see what kind of a prototype of the parabola it is becoming. So for that, we of course complete the square. X square plus 2x minus 3. So this is minus x square plus 2x minus 1 plus 1 minus 3, right? So this is minus x square plus 1 plus 2x minus 4. This is minus x plus 1 का square minus में 4. This is minus x plus 1 square plus में 4. So this is y minus 4 equals x plus 1 square. Now we'll plot this is like a y equals to minus x square kind of graph. So what we'll plot y equals to minus x square. This is like this, right? This is y equals minus x square. Now what we have to change to plot y equals to x plus 1 square. This will be like y equals minus x minus minus 1 square. So our h is negative, so it will shift towards the left, and that to 1 unit, right? So this will be like this. So this is the graph of y equals minus x plus 1 square. Now further you have to make a change in y, and that here is y minus 4 equals minus x plus 1 square. So this h is positive, so it will shift the graph upwards. So finally the graph will be, and that to 4 units. 4 units upwards. Here is 1, right? This one will minus 1 comma 4. This you for the proper plotting, you just see where it cuts the x y axis. So right, so these points are 0 comma 3, 1 comma 0, and minus 3 comma 0. So this is the graph of y equals 3 minus 2x minus x square. So you can see how useful these shifting formulas are. Now the last question of today, question number 9. Is on composition of functions. So fx equals x minus 7, gx equals x square, and find what is f of g of x and what is g of f of x. So you just have to see that f of g of x is f of x square, and f of x square will be x square minus 7. Whereas f of x is x minus 7, f of x square will be x square minus 7, and g of fx will be g of x minus 7, and gx square is the whole function. This is x minus 7. Now your exercise is to, so you see that f of g is not exactly equal to, not always equal to g of f. So now exercise, find the domain. So you see that for fg to be defined, the range of f must be contained in the domain of g. Then only this will make sense, right? That the range of G should be contained in the domain of F, so that this Gx will make sense for the argument of F or the domain of F. So find the, you have to, the domain and range of F of Gx and G, you should rather write not X of F of G and G of F, and plot F of G and G of F. Okay, so that's it for today. I hope everybody was able to understand. Now I will wait for students if they have any doubt. I'm here. Let me know if you have doubts. Thank you.